For these problems, we need to think about z-scores and the empirical rule. Now, a z-score is how many standard deviations above or below the mean an observation is. So considering that the class average was a 78 and Ruth scored a 73, she was 5 points below the average, which is 1 z-score. To do this, we can take 73 minus 78 divided by 5. That is observation minus mean divided by standard deviation. Next, the mean weight of a breed of yearling cattle is 10,090. Suppose that it is normally distributed with a standard deviation of 99. How many standard deviations from the mean would a steer weighing 1,000 pounds be? So, we need to know what the difference is between these two. Observation minus mean. Mine's really easy. It would be 90, because 1,000 minus 1090 is negative 90. With this in mind, we need to put this into terms of standard deviations. 90 divided by 99, 90 divided by 99 is 0.9090 repeating. Now, there's two ways to answer this. You can answer this as a positive or a negative, and mine will round up. An important note here is, this question asks how many standard deviations below the mean it is. If we were to say a z-score here, we would need to put negative 0.91. Now, which of these is more odd? The one that would be more odd is the one that is further away from the mean. 1,000 is only 90 away from the mean. 1,250 is 160 away from the mean. Now, we could turn these into z-scores and see which one has the larger z-score. But with this in mind, a z-score is just how many standard deviations something is away from the mean. So the further something is away, the larger its z-score, and the more unusual it would be. Going on to the next question here, we are going to use the empirical rule, the 68, 95, 99.7. You'll notice that this is kind of like Goldilocks here. Some of them are too small, some of them are too big, and some of them are just right. So let's look at a few right here. We have that we need a standard deviation of 7.2. So this one right here on the right, you might have to zoom in or look very closely. 7.2, and actually it looks like on my first try I have found the right one. So the one on the right has the just right standard deviations. Right here, between 25.8 and 40.2 is way too large. So this one has too big of a standard deviation. Going down here, it should have too small. These standard deviations are generally about a half. Sorry for the small text. I don't think there's any way to actually increase the text. Now, you will use the one that you have checked. So make sure you select the right one to start this problem. When we do the central 95%, we're talking about in between -2 and +2 standard deviations. So right here, 11.4 to 40.2. Make sure you know 68, 95, 99.7. It's a huge help. It's repeated throughout this whole problem. About blank percent of autos should get more than 33 miles per gallon. So this is where it can get a little bit tricky. Going over to the graph right here, 68 is in the middle. So with 68 in the middle, we must think of what's on the outside. What is to the right of 68? Well, total outside of 68 is 32%. If 68 is in the middle, 32% is over on the right and the left, cumulative, which means to get just one side, we would take 32% and divide it in half. So that'll give us 16% is above 1 standard deviation. About what percent should get between 33 and 40.2? So when we go over here to 33 and 40.2 on our graph, that is in between 1 and 2 standard deviations. Now this is where you need to be able to break down the whole graph. If you can break down everything and fill in all the percentages, you will get over here, if you watch, going from left to right, 0.15, 2.35, 13.5, 34, 34, 13.5, 2.35, 0.15. How we obtain 13.5 in between here? With 13.5 in between this area, we can look at 68 and 95. Now, if you notice, 68 is contained in the 95. So subtract out the 68 from 95, and you're left with 27% remaining in these two areas. So with 27% total, we can divide that in half and get 13.5 right here. This takes a little bit of practice, but be able to break this down completely and know how much area is in each section. Describe the gas mileage of the best 2.5% of cars. The best 2.5% of cars would be the cars above 2 standard deviations. And this one's a little easier to see because if 95 is in the center, well then 2.5 is on this side and 2.5 is on this side of it. So above 40.2. Going on to the next question, we are going to use the 68, 95, 99.7. Going on to the next question, we are going to use the 68, 95, 99.7 rule again. So with this in mind, you'll notice that this middle one has the numbers completely wrong. So let's take a look here. We are down to just C and A. So we need a mean of 10.7. That automatically eliminates C. Hey, C has the wrong mean. So let's go over here and choose A. This will be the problem we will use, or the solution we use throughout the rest of this. What size would you expect the central 68% of all trees to be? Well, that's just the 68, 95, 99.7 rule right here with -1 and +1, 68% in the middle. So it would be 6.2 to 15.2. About what percent of trees should have diameters below 1.7 inches? Going right here. 1.7 inches is 2 standard deviations below the mean, which means, looking at the 95 rule, 2.5% is on this side and 2.5% is on this side. So about 2.5% of trees. Using the 68, 95, 99.7 rule, what trees should have between 15.2 and 19.7? So let's take a look. 15.2 and 19.7 is between 1 and 2 standard deviations again. This is the trick when we take out the 68 from the 95. Look closely. If you take out the 68, you'll be left with just these two portions on the outside of it, meaning that you have 27 divided by 2 to get this one, giving you 13.5%. Using the 68, 95, 99.7 rule, about blank percent of trees should have diameters over 15.2. So let's see where 15.2 is at. 15.2 is 1 standard deviation. Again, 68% in the middle, that leaves 16% on this side and 16% on this side. So we have 16%. So let's talk about one last thing with this problem right here. A lot of people, as we see an advertisement for Flash, let's go to right here. I'll try to zoom in for everybody. With this in mind, here we go. Here's my favorite graph with all the areas in. It's important to be able to label all these areas. This graph is more broken down than we generally see with the 68, 95, 99.7 rule. Be able to draw this out. It also has the standard normal below it, which is excellent to paste in below your graph. Anytime you're doing a problem on a test, you should be able to draw this out and relate your answers to the standard normal labeled below or your general answer labeled on top of that. Another great thing to do, and we can pull up that graph here too, is to look at the cumulative percentages. And there is one in Google that has the cumulative percentages. Let's find it real quick. If you'll notice here on this normal curve, they've labeled out the percentages for you. It has tons of info. It even has for you where the Q1 and Q3 would be in the box plot. Looking right here, we can see the percentages between, and this one is more exact than U would be. But on ours, we would have a cumulative percentage running down here. We would have 0.15, 2.5, 16%, 50%, going over to, it would be 84%, and then next we would have 97.5, and we'd have 99.85. So you can actually draw one out yourself and know how to get all of these numbers right here. Lots of information supplied in this normal curve.